2.7, use absolute value functions and transformations. What does the parent function of an absolute value function look like? What does that parent graph look like, meaning? What's the equation that we use for graphing absolute value functions with transformations included? What do the h and k do? And how is a similar to slope, but how is it different? So whenever we start learning a new graph form, we're going to start with a table, because if you forget everything you know, you can always go back to a table. So a function, I could write it in function notation, or I could write it in with a y. Those are saying the same thing, right? So I just want you to know, if you're comfortable with one, you need to be comfortable with both. They're going to be the same thing. So we're just going to, because we're working on a graph that's centered at the origin, we're just going to pick points near the origin and stick them in. And if I stick in 0 for x, I get y equals the absolute value of 0. Absolute value of 0 is 0. So when x is 0, y is 0. Let's do a couple more before we graph them. Y equals the absolute value of, let's do -1. Well, absolute value of -1 is 1. And then let's do the positive 1 also. Absolute value of +1 is 1. So if I go over here, when x was -1, y was 1. When x was +1, y was 1. And we can make a supposition, and I'm just going to talk through the next couple. If I stick a -2 into the absolute value, what's the absolute value of -2? 2. What's the absolute value of +2? 2. So now let's graph that. This is the parent function. So whenever you see an absolute value function, this is what should come into your mind. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is -1, y is +1. When x is -2, y is +2. And it's going to continue that way. So whenever you see absolute value, just think of that big V. And I'm trying to draft it really carefully because I want you to get that picture in your mind. Luckily, absolute value starts with a V, so you can use the little memory trick. And so we're just going to take that V. Hopefully that reminds you of something from Algebra 1 that you graphed. Hopefully it kind of reminds you of a pointy parabola. And that's the basic one that we're just going to do things to and let it move around the coordinate plane and change in various ways. So we're going to start with this absolute value function, absolute value of x minus 3. Notice I've graphed the parent function very lightly over on the graph, just so you can keep that in mind and so we can decide where we want to go when we start doing these points. I'm going to start with 0, -1, 0, 1, and then we'll decide where we want to go from there. So I'm just going to start plugging them in. Absolute value of -1 minus 3 is -4. Absolute value of -4 is 4. So when x is -1, y is 4. And then we'll plug in 0. Y equals absolute value of 0 minus 3, -3. So then we get absolute value of -3 is 3. And then we'll do one more before we kind of graph a few and decide which way to go. Y equals absolute value of 1 minus 3, -2. Absolute value of -2 is 2. Okay, so let's graph those and then decide where we want to go. So we said -1, 4, and 1, 3, or 0, 3, and 1, 2. So that's the line we have starting. And so I'm going to make a guess and a conjecture here. I want to go to the right. I think more interesting things are going to happen to the right. So I'm going to go 2, 3, 4. And we might go that far, we might stop. Let's see. So we'll go y equals absolute value of 2 minus 3. That's -1, which is 1. And then y equals absolute value of 3 minus 3. That's absolute value of 0, which is 0. Okay, and then let's do one more. Y equals the absolute value of 4 minus 3. 1. Absolute value 1 is 1. Hey, something happened. That was interesting. That was 0 and that was 1. So last time we got 1, 0, 1, but we were at the origin. Now we got 1, 0, 1. We got 1, 0, 1. So look, that whole function just moved over. And we could keep doing points. That's what it... Oh, that's not good. What happened? Look what happened. It just moved over. Do another one that's slightly different. Let's do that. So, again, I'm going to do some, start with -1, 0, 1, and then we'll decide which way we want to go after we do those. And I'm going to do these more quickly. This time that number -2 or -2 is outside, so it does not get affected by that absolute value. It gets done afterwards. Let's see, so -1 is -1, and then y equals absolute value of 0 minus 2, so that's -2. So we got -2, and then y equals absolute value of 1 minus 2, absolute value of minus 1, 1 minus 2, -1 again. Okay, well I see that up and down pattern already, so I don't think we need to do any more points. So we have that up and down, or down and then back up pattern, but this time 0 gives us -2. It's down there. So this time it just moved down. So I want you to think about that -2. If those absolute value brackets weren't there, wouldn't that just be like your y-intercept? And isn't that what this did? If I looked at, okay, don't graph this, but just think. This is a thinking time. If I have this line, that looks like, this. It just keeps going down here. Well, think about it. We can't keep going down here because absolute value can't go negative. So it just flipped up and became the negative version of that, right? The opposite version. Change the sign. Y equals a x minus h is inside the absolute value. That h is inside x minus h. It comes with a minus, just like point slope forms, x minus x1, just like equation for slope has the minus, just like distance formula has the minus. Then this k outside is a plus k. And that equation, we're going to see lots and lots of equations all year that are based on similar things. So that's the equation for an absolute value function. So anytime you're going to graph one, you need to be thinking of how it compares to this. So we've got to learn how to read this. So I'm going to do an example. I think that's the easiest way. If I do the example first, then we'll talk about what to do. So I would watch first and then write. So I'm going to do y equals x plus 4 minus 2. Okay, so first thing I'm going to do is I'm going to write down what a is. A is 1, because if it's invisible, just like a slope of 1 would be invisible in a line, in slope-intercept form, since there's nothing in here, the slope is 1. Okay, and then h is -4. Think about why h is -4. And then k is -2. So why did one of those get a negative, or why did both those get a negative when the equation looked the way it does? That hk is going to be our vertex. Right? That's an E there. Vertex, just like vertex in geometry. And maybe you remember vertex from graphing parabolas in Algebra 1. Now I want you to think, when you see that a equals 1, what would a slope of 1 look like? Right? Slope of 1 going up to the right, but not too steep, not too flat. Well, it's going to be a V shape with that when a is 1, just like we've seen. So all we've ever seen so far is one with a slope of 1, with an a of 1, I should say. So we said our vertex is going to be at -4, 1, 2, 3, 4, -2. And after that, it's just a matter of using that a as a slope going up to the right, and then a mirror image on the left. I ran out the graph, so it looks like a check mark instead of a V, but it would keep going, right? The arrows mean it keeps going. So what happened is it moved 1, 2, 3, 4 to the left, and it moved 2 down. We call that a translation. That's one kind of transformation. So that's what the H and K do. The H, well, let's go back up to the formula now, and now write in what they do. What A does is if A is positive, it opens up. If it's negative, it's reflected. Remember, reflections, that just means, you know, the whole thing flipped over. If it's negative, it opens down. You might remember that from parabolas in Algebra 1. Same thing here, and we're going to see that again soon here. That's one of the jobs of A. A also has another job. If A is, this is where it's kind of like a slope, right? If the absolute value of A is greater than 1, so basically if A is 1 or 2 or 3, well actually, yeah, then it's going to stretch it upwards. Now these words are a little iffy for me sometimes, so I have to think, if I stretch upward. It makes it skinnier, narrow, skinny, right? Tall, right? Think about what that would look like. And then if the absolute value of A is between 0 and 1, basically if it's a fraction that's between 0 and 1, because if it's a negative, we know it just flips over, then it's a shrink. And again, that is kind of weird for me. It just means it's really flat, like a slope of 1/2 or 1/3, right? It's wide or flatter, right? So hopefully some of those words work better for you. What you'll see in the book is shrink and stretch. I tend to talk in terms of narrow and skinny and wide and flat. H is the horizontal shift. That's why it moved 4 to the left. And K is the vertical shift. That's why it moved 2 down. Both of those were negative, so it moved left and down. And so H and K together always give you your vertex, right? The point where it changes direction. And that's just like in a parabola, and we're going to see that in other things too. H and K is always an important point. So the parent function of an absolute value, remember, it's just the origin and then a slope of 1 up to the right, basically a slope of 1 to the left. So, but they're not really slope, it just works the same. What does the equation for graphing absolute value functions look like with transformations? That's the whole big thing with the H and the K. Talked about what those do. And then think about, why am I saying that it's kind of like slope but kind of different, that A?